welcome everybody on behalf of the BCS Animation and Games Development Specialist Group, in addition to those from the Hampshire branch and the Dorset branch. And we have a fantastic speaker today, which is Ian Hughes, Dr. Ian Hughes, who is actually the chair of the Animation and Games Development Specialist Group, and very well known internationally, particularly within the industry. So at that stage, I'll pass across to Ian. We are actually going to be recording it. We do not normally record during the actual. We don't normally take questions during the actual presentation. So if you can put your comments and questions into the chat, and if you could keep your microphone off during the presentation, that'd be marvelous. So at this stage, I'd like to introduce Ian Hughes, Chair of the Animation and Games Development Specialist Group. Over to you, Ian.
Excellent. Thank you very much, Margaret. And thank you, everyone, for turning up on this wonderful Thursday evening. So, yes, as Margaret said, I work in emerging technology. I'm an industry analyst, so but I've been in the industry quite a long while, doing all sorts of unusual, interesting things. Now, I wanted to just pull some of the things together that we maybe hear and see and talk about, and just try and understand where everything maybe fits together. So hence emerging technology, buzzwords, hype, and real change, which probably should be a question mark on the real change. So online, I'm known as ePredator. You may have bumped into me before talking about stuff, but I've been in a lot of online places doing a lot of stuff, and particularly in the world of metaverse and stuff. That's where I'm most well versed, I think, for the past sort of 20-25 years. But I also train in a martial art called Choi Kwan Do, and I've just started training in Tai Chi, which will become relevant in a weird way very shortly. I also presented for a couple of, well, quite a few years ago now, but I had my own slot on a kids' TV show to present this kind of unusual emerging technology to 7 to 11-year-olds. So I like talking about this stuff and trying to help people understand where it all sits. Brief plug though, I've written a couple of science fiction novels, which I wrote before I started being an analyst, and these are all about a lot of the technology I'm about to talk about, a lot of AR, VR, quantum, IoT and stuff. It's all thrown into this mix, and a gamer main character who's also a developer. So make of that what you will as where she comes from, because I am a gamer and developer by trade. But again, this may or may not be relevant for you, but they're only 99p on Kindle, so I thought I'd just share that with you. But I want to just start with a little bit weird serendipity that occurred. So Margaret asked me to do a presentation to Bournemouth Natural Science Society a year ago. And as part of that, it was about generative AI, which is obviously the flavour of the month. And I thought, oh, I'll just ask Gen AI to create me a Bournemouth Natural Science Society picture. And it came up with this, which is very nice. I mean, there was 4 pictures it generated on Midjourney, but it came up with this. So this is an AI just going, well, no more information about what Bournemouth Natural Science Society is. So it sort of just did something sort of natural. But this year I presented to them again, and I happened to think, well, I might as well use exactly the same prompt on exactly the same system on Midjourney. And it ended up with this circular rendition rather than the sort of tapestry that did before. And I was kind of quite taken with that. And you may spot why this is relevant, and if not, I will show you in a minute. So I promise that you'll spot why that's relevant. Anyway, so this started really this was all about the fact that working in emerging technology and in technology in general, which many of us do, I suspect, and I apologise to those of you who are specialists in any of these particular areas. I'm skimming over absolutely everything, but there's a confusing set of acronyms, and these aren't all of them by any means, that sit out there in the tech world, and particularly in the emerging tech world. And what we tend to do, and like the BBC does it when they talk about it on the media channels, when they say, here's the acronym, we'll expand it out for you because that'll make life all right. It doesn't. It makes it even more complicated and messy because there's a whole bunch of stuff and words and things, and none of it necessarily means anything to anyone unless you are engaged in that one particular thing or a couple of them. So I was trying to kind of straighten this out a little bit and see where these start to fit and what built on one another, and where how people might be able to absorb this information, whether they're BCS techies or whether they're in other industries or other places. But before I dive into this enormous list of things, which as soon as I made the list, I thought, why have I done this? That's too big a list. I want to just have a pause for thought on how we think about and how we try and understand what's going on in the world. And I've got a couple of sort of underlying philosophies about where these things fit. And one of the things is that definitely the more you know, the more you realize you don't know anything. And that's, once you get used to that feeling, that becomes less of an issue. So if you think, oh, I don't know about X, Y, Z, you probably do, but you don't. And even if you looked into it, you might be an expert on it. And as soon as you're an expert on it, you realize there's all the other things you don't know about it. And as the late Daniel Kahneman said, we're blind to our blindness. We have very little idea of how little we know, but we're not designed to know how little we know. But I think once you kind of accept that there's always something to learn, you never know absolutely everything, life gets a little bit simpler. And the other thing is thinking fractally. So fractals were very big when I was at university many years ago. And fractals as a repeating pattern, a simple repeating pattern, typically mathematically generated pattern, to represent the whole of something. They often talk about coastlines and things like that are all made from, if you're close to the coastline, it's as complicated as if you're far away from the coastline. And many of you may have dabbled with things like Mandelbrot set, which is a mathematical plot of an iterative formula that has both this beautiful simplicity that we all probably recognize this image, but an incredible complexity to it, because you can just keep using the maths to get closer and closer in, rendering more and more detail, but just repeating the patterns, and it just goes on forever. And I'm not going to do a 90-minute or an hour's worth of zooming into the Mandelbrot set, but you can start to see sort of in the upper left-hand quarter, there's the original Mandelbrot set is almost there again. And so this notion of this repeat and these patterns and these things, and it doesn't matter how close or far away you are from it, it's just as simple or as complicated, I think is a useful tool for when confusion strikes. The other thing with fractals is that I was particularly taken with this again when back in the late 80s, that there was this algorithm for this Barnsley fern, this completely computer generated fern. So let's say this probably goes back even further than that, but this is a fractally generated fern, and the pseudocode, albeit from Wikipedia, I didn't want to make this too complicated, but the pseudocode on the right there just is saying pick a random number between 0 and 1, and then plot a pixel based on a few little boundary rules there. And then it takes that, where that pixel was, that randomness, and feeds it back in again. So it gets random on top of random. I know random in computing is a bit weird, not necessarily totally random, but it's enough that this thing, through enough iterations, generates this kind of fern. And each of those leaves is a copy of the bigger leaf. And again, this is the same. This is just a better way, or a simpler way, possibly, to think about how that Mandelbrot set works. But I want you to think about how this works in how we think about stuff when we look at the detail of something, or the simplicity or complexity of something. Now, the other thing, and this is kind of where my meandering into Tai Chi and different from my Korean martial arts into a more serene, if you like, Chinese martial art, is that the concept of yin and yang. Now we all say yin yang, we see things bouncing off. We all recognize this symbol. I hope this is sort of a symbol that has been around for hundreds or tens of thousands of years, if that. And one of the things about this that to me, it always been, oh yes, it's black and white, it's strong and weak, it's good and bad. And but when you look at this thing, it's the actual underlying piece of this symbol is that it's a circle, so it's got everything in it. So absolutely everything. There's an infinite amount of space within that circle. and the yin and the yang are in constant swirl. The black and the white are not divided down the middle. It's not binary. And also in the yin, there is also a little yang. So, and vice versa, there's a little white dot inside the black and a black dot inside the white. So there's a constant swirl and one thing with another. So it doesn't mean that it's just strong and weak. It means it's everything, and there's subtlety, and it's a non-binary thing despite being black and white. So in computing terms, we do 1 and 0, black and white, but this isn't. And so it started to me to feel a bit more like, if when you look at it, even though there's a simplicity on top, we're kind of in this fractal world again of what detail does that mean? Where does it go? How do we, what parts of that do we drill down into? And that's where the previous weird generation that I got for Bournemouth Natural Science Society, I wasn't even thinking about doing this yin yang symbol thing in presentations, but you can see from what happened that even though I'd not expressed anything about that to Midjourney, this thing popped up, and it's quite similar in a lot of ways in the swirl and the curve, and even the fact it's circular to yin and yang. So this is a serendipitous thing that I also is one of my things. I just follow serendipity. So if something is a coincidence, that doesn't mean you ignore it. There's a balance between getting worked up on it being coincidence or trying to make coincidences happen, but seeing patterns and seeing things are all part of where do you go next and what do you do and what you talk about. And so the reason I'm talking about yin and yang is because it generated this, and I thought, oh, that's weird. It's where I am and what I was just thinking about on the yin yang symbol. So that's partially the techno heavy thing out of the way, but I hope it's relevant in the conversation, because I shall pop these along in later on too. So let's get back to this confusing list of words, because that's what we were talking about. Huge loads of expanded acronyms, and I tried to sort of initially try and break them down and group them into some sort of semblance of similarity-ish. Some of the ones aren't, because I ran out of space to get all the categories. But trying to categorize things is always difficult, as you probably all appreciate. But let's give it a go. So the first thing, and again, I apologize for any of you that are pure techies in any of these, or that know lots of this stuff. This is a way of us all, even if we do know it, to kind of do that zoom out in a Mandelbrot set way and think, oh, what's the complexity? Or zoom in, where's the or zoom out, where's the simplicity? Zoom in, where's the complexity? And so cloud computing, the company I worked for was, or the industry firm, or analyst firm I worked for, was originally formed back in about 20 years ago to help deal with the confusion over cloud, because nobody really knew what it was going on in business. For us, it's, as techies, it was like, well, it's fairly obvious, isn't it? Because we've been doing client server stuff for years, and I started on green screens talking to mainframes. And so the fact that there's a cloud, I know it's got more clever, and we've got elastic cloud and things, but the processing and storage and stuff is happening somewhere else. The thing is, now we've got cloud that can stream interesting information back to us, not just individual packets of information, but whole applications, whole views of things. But at the same time, now everyone started getting confused about edge computing, and so edge computing became a thing to people to talk about, which is really the computing coming back to near where the data is that it needs to process. And so we get a lot of edge computing in industrial machinery. So you put processing on the machine rather than sending all the data to the cloud, because why would you? Well, you don't need to send all the data to the cloud. But this is a typical example of people, there's lots of buzzwords and lots of stuff, and it's all great, but it is just a continuum, and it is a fractal pattern of input, process, output. And it's the same thing as that if you understand anything about how computers and computing works, it can be applied to any of these areas, whether it's edge, cloud, or somewhere in between. And so again, we get people stuck on things, or particularly non-technical people might get stuck on things going, oh, we must only do it in the cloud. That's not how life works. It's much more fluid and flexible, and as I said, a continuum fractal pattern. So that's the simple one. The other, not a relatively simple one is all the G's that we have in mobile, in the mobile network. So I've left off 1G and 2G on this, but we had 3G turn up, and suddenly it was a thing that was different for mobile phones. But really, it was the fact that a mobile phone was doing circuit switching, so making a direct, albeit over wireless, but making a direct or radio waves, a direct contact connection effectively over a network between each caller for the voice call. So that's exactly the same way as old telephones worked, when you put a plug in a switchboard and you just had wires basically connecting you together, or Strowger switches or digital exchanges and all those things for making those direct connections for traditional phones. But it started to introduce some packet switching, some more internet-like approach to delivering data. So it wasn't the voice call, they'd separated that. It was the data. It was how SMSs got, kind of how we got early access to the web. And this is about saying, well, we don't send all the data on the same path all the time. It might take a different route. There's not, there's loads of stuff you can do in tuning it. But when we got to 4G, everything became packet switching effectively. Now, this didn't all happen. It's not clear, this boundary. This is a continuum again, because you have 3.5G and 4.5G and stuff. But basically 4G was more like packet switching for everything. Voice became the data packet as well. And 5G, which was the one that probably most people got more excited about, was actually doing more of the same, but this time trying to add some digital priority on certain types of data. And so you could potentially reserve slices of the network to say, well, this is where the really fast important data has to go, and the slower stuff can go in across here. So it's almost gone back to a circuit, but not. It's more of a channel, but it's very similar. So we've got another circular thing going here. If you understand circuit switching, then you understand network slicing, I would suggest. 6G, which is 2030 or whenever, is really taking all this stuff, which is getting incredibly complicated how you route all this stuff, and bung some AI into it. So basically using more processing power, typically edge processing power. This is a different kind of edge. This is on radio towers and stuff, but to help understand where data needs to go and manage it, and also run at higher frequencies, because you've got something more efficient to understand where everything needs to go and where it needs to fit. So we've gone from old switchboards plugging in to AIs plugging us in across the network. So it's circuit switching to packet switching, tiny little pattern. Again, though, it's another fractal pattern, because those things they repeat, and packet switching is how IP networks work, how the internet works. And then just to ramp this up, quantum computing. Now, I am not an expert on quantum computing. I like quantum computing. I've written about it in science fiction terms. I've done the odd presentation on it, but basically it's mind-blowing stuff. So our conventional computers use ones and zeros, so everything is binary. We do processing on being able to change those ones and zeros iteratively, as many times as possible, not iteratively, quickly as a loop, as many times as possible. And the faster you can change all those ones and zeros, the faster your computer and the more compute power you have. So you keep going until you reach the answer. Everything in that world is based on an AND gate and a NOT gate in logic terms, and you wire enough of them together and you get all this stuff. Quantum computing, though, treats 1 and 0 as a range. So an individual bit of quantum knowledge, a qubit, is everything, every possibility between 1 and 0. And this it's kind of called superpositioning, but this in itself is freaky. But if you consider what happened in that fern leaf where we had the Barnsley fern, everything was based on the randomness of probability between 1 and 0 to generate the leaf. Everything was between 1 and 0. And so it wasn't 1 or 0, it was the range. So you can kind of start to find again a pattern of, well, it might be a little bit weird, but there's at least something that I understand or can get my head around that helps this fit. The weirdest bit, though, is that these qubits, you can have two qubits entangled, which across any distance, across the other side of the universe even, and if one of them changes, the other one changes the opposite. So there's always this balance that the value is, if one thing changes, the other thing changes. So you can use it for things like communications and crypto and all sorts of unusual things. And it all happens at the edge of what we call normal physics, all the school physics we learn, and it happens towards absolute zero temperature. But the thing is, a quantum computer looks at every state in a problem space all at once, and basically the results of probabilities. Now, every time these sorts of things kind of get in my head, I think, oh, this is weird. Life can't be that complicated. And then you come across something like the fact that a deck of cards, 52 playing cards, small deck of cards, you can hold a deck of cards, has got 52 factorial combinations. So there are, just in a deck of cards, informationally, you've got 8 times 10 to the power of 67 combinations. And so you can see that whilst between 0 and 1, it might seem weird because it's a small boundary, there's actually everything can fit into that. And 10 to the 67 isn't infinite, but it's quite large. It's more than we can generally cope with, and more number of atoms on the planet. So quantum sits in this weird space, but it's also very yin and yang. If you think about it, we've got ones and zeros, everything combined. It's all bounded in this, yin and yang can almost be, this symbol could almost be a qubit, and the whole of quantum computing. Now, I did do the general thing that everyone does now and asked ChatGPT what I thought quantum computing used for. Not because I didn't know, but just I wanted to see what it was going to do, because I like to experiment with the tools. And so it came up with drug discovery, because there's lots of combinations there. The interesting one, I think, though, is optimization problems, trying to understand how to get everything from A to B, whatever it is, whether it's logistics, supplies, whether it's how to reroute a chip if you're doing chip design. All those kinds of things all kind of fit in there. And then the kind of elephant in the room on this stuff, which is about cryptography and cybersecurity, because all our cybersecurity is based around having a really complicated number that takes a long while to iterate around to crack. And quantum goes and does it instantly, because it knows it solves the entire problem in one go. So that then leads to having to use quantum cryptography to find ways to lock everything up. But it does mean that everything on the planet that's got regular cryptography, when this stuff opens up, that's kind of up for grabs, I would suggest. Then there's my kind of underlying expertise, if you like, in how we engage with computing and what we do as people, and how we see this stuff. And I'll just start with this, how we experience computing, because this is the easy bit. And if you look at that picture there, we've got a laptop on a desk and a rock and looking out the window and a tree and all this stuff. So if you were there and you were looking at that, would you say that's 3D or 2D? And if you're physically there, then obviously the world kind of is probably 3D, but the screen you're looking at is 2D, but it's a picture of something that's a mountain that's actually 3D and fractal, I might add as well. And so you get this kind of weird balance of, you can argue where you are, whether something's 2D or 3D, just as you can argue whether it's virtual or real. Which bit is real in the world that you're looking at? Is it because the screen's there and the pixels are on there, but it's not actually a mountain, but you see a mountain and your brain's perceiving a mountain, so it's kind of a real mountain. Is it digital or is it physical? Same thing. It all sits in that space. Mobile or static used to be, people talk about mobile computing all the time. I mean, this is a laptop's mobile, but you can't easily use it while you're walking around. So it's both. And then, are you seeing, if you move your head, what happens? Does the picture you're looking at change? And what you see, and in the physical world, when you look around, your perspective on things changes, particularly binocular view of the world. But equally, you can scroll around with a scroll bar on an image on a laptop. So fixed dynamic view. But the thing about this is that we're back in yin yang territory, because we've got this, it's everything. And so almost worrying about which thing it is it real or virtual, is it digital or physical, it's all part of the same stuff. It's all part of the same mix. And so you can get hooked up on too much on some of those particular elements of it. So that brings us to the realities. So we've got virtual reality, augmented reality, extended reality, mixed reality, all the flavors and versions of those that have been around for years. And now Apple's come along and called it spatial computing because it's all of those, because they don't want to differentiate and get dropped into something that seems old or stale. Other companies are now talking about volumetric computing. But this whole thing is about dealing with not just flat screen, but with space, with depth, with where something is, not in forwards and backwards, left and right, up and down. And we also in this have the emerging things of light field displays. And LFD light field displays are not about all these headsets and all necessarily and all these things you strap on your face, but this is about often about creating a screen that's different. So all our screens are projecting pixels straight out at us. And we try and get those pixels to create an image, and we maybe move an image and give it a sense of depth. But a light field display actually directs every pixel in the right direction that the beam of light should go. So you end up actually with a 3D display, but not in a crunch your eyes way to try and make you think it's 3D. It is 3D because the light is where it needs to be, and the light is in front of the screen. Each beam of light is in the right place. It's an incredible piece of engineering, and there's lots of clever ways of doing that, but it's very, very different to the blue-green glasses or the LCD shutters or even the kind of triangulated displays that you see on for fake 3D. So those things are kind of kicking around, and within all these, we've got we've got things to help us navigate computers. We've got these 2D screens. We've got mice to move stuff around, which you think it's kind of 3D, but then it's got a scroll bar on it and buttons and stuff. So it's actually, you can bring things in and out. So we're already not just 2D. And then we've got these headsets and glasses and stuff, all, Quest 3, Vision Pro, all sorts of things kind of turning up. And those are about 3D input and 6 degrees of freedom, up, down, left, right, in, out. So when you look at something and you move and you change, it knows. So you're not fixed. Like when you look away from your screen, you can't see it anymore. In the physical world, if I need to take the screen with me in mixed reality, for instance, I can have it pinned so that wherever I look, the screen is. Or if I'm in a virtual reality experience, I can turn around and something's behind me. I turn back around and the thing I was looking at is still there. And so we've got this change in how you might access information, but it's not necessarily all about headsets, all this stuff. We've also got spatial audio. We can't forget spatial audio, because that's another incredible part of how these things go, and haptics, which I didn't even put on here, but how you actually kind of feel what's going on in these environments. But that takes us on to metaverse, and particularly this not necessarily being about headsets. And everyone goes, oh, metaverse is dead. Well, it's not, because this is an ongoing thing it's the evolution of how we engage with one another and with digital artifacts in ways other than QWERTY keyboards and flat screens. And things do change and already have changed. But when you think metaverse, a lot of you maybe think, oh, it's just Facebook renamed themselves, or it's just Roblox, or it's just a video game or something. There's plenty of examples of that. But one of the things, so S&P Global has defined the metaverse there. I'm going to read it out so I get it right. So defines the metaverse as the long-term vision, so it's not here yet, for the next phase of the internet, which will feature a single shared, immersive and persistent 3D virtual space where humans and machines interact with one another and with data, enhancing the physical world as much as replacing it. So when you hear metaverse, or you hear any of those things, it's not just disappear off, it's bring things to you, to where you are, to where you need them, in whatever way, shape or form it needs to be, typically uniquely, or engaging with other people and other things. But it's not just us as people, but it helps us as people. And it's also a complete spectrum again, just like in a sort of yin and yang way. It's everything from on the left there, it's the most ethereal, non-existent place and things, across in the middle there to sort of gaming environments that are a bit like our own environment. You know, we often have a planet or a land or a thing. The creatures inhabit it might be different, but it's closer to our physical world. But then it moves into industry, and I'll talk about some industrial stuff in a minute, in the industrial metaverse, and also into augmenting our view of the world. So providing the information we need, where we need it, just as your GPS does in your car. So you're wandering around on your phone, whatever. It's digital information being given to you in a certain way that wouldn't have been there otherwise. And these are all the seeds and the early part of understanding that we don't just have to sit in front of a laptop listening to me talking, which is unfortunate because I like doing that. Yes, Ready Player One does sum up the metaverse in a lot of ways. It was on the chat. And even, you know, Ready Player One has got the writer of Ready Player One as a company that's building some metaverse type experience as well, just as Neil Stevenson from Snow Crash, who coined the metaverse word in the first place, is engaged in a lot of these applications that are building this stuff. But it's almost, we don't necessarily expect it to just magically appear one day and here's the metaverse. This is an ongoing evolution of how some of our interfaces work, the things that we do, where we are, where we go to consume interesting things. Disney has invested $1.5 billion in Fortnite, for instance, and they have got all the IP for Star Wars and Marvel and Muppets and everything. What's going to happen? It's going to turn up in there. And so is that where you go rather than to the telly or to the web? And so we'll see. It's an ongoing project, but I would suggest, well, go and find me my day job if you need to know even more about the metaverse. But we've got consumer and enterprise and industrial and art projects and open source and stuff. There's a whole range of interesting things to keep an eye on with all this. And then creating and manipulating 3D content, which is an interesting one. A lot of stuff in the old games world that we're maybe more used to. I was basically talked about polygons. There's been a few other things, but polygons, triangles of positional information of a triangle. It becomes a surface. You put enough of those triangles together, you get facets together, then it forms, as you can see there, sort of nearly a sphere. The more polygons you have and the more triangles you have, the smoother the sphere. But then the more processing you have to do. And in many ways, again, we're kind of in fractal space there again, but that had been the basis for most things, had been around understanding polygons. But then we've ended up with things like Gaussian splatting and neural radiance fields. So Gaussian splatting on its own is the Gaussian thing is using a curve to represent represent the piece of information. So putting curves together rather than triangles together, which gives more mathematically smooth and interesting ways of representing stuff. As again, it's a huge compute challenge. Neural radiance fields are a branch of AI, and that is about training a model to understand where a pixel is in space. And we don't necessarily, I mean, the model becomes the thing that you then position a camera on and see wherever you position the camera, you get the right view of it. Gaussian splatting is kind of dropped into that as well now also that's also used to create whole AI trained models of a space from a number of photos or a piece of video or anything like that. And what those things do is they take all these separate images and they don't just stitch them together, but they look at the images and then they work out where each part it may see is likely to be in the whole 3D model. And the more times they see it, the more precise it gets as to where it is. So this weird picture of the front of my house, or the scrubland in front of my house, is from a nerf that I created by just walking around with my camera, just taking a film around this island in the middle of a sort of little garden thing, and then it trains itself on all those. And now I've got a thing that I can effectively fly a drone through into places that I didn't put the camera. So this camera is now sat and taking a photo, effectively took a photo of somewhere that I hadn't physically been. And so this has created a world. And so we're kind of back in metaverse territory here, because it's a 3D environment. This happens to be a mirror of a physical environment, but the way that we can engage with data and fly through it, and whether it's real or physical or digital or weird, is all changing. And we also under the covers here, there's in the world, there's Open Universal Scene Descriptor, which is very good for us as techies, I think, because this is an emerging standard that is trying to help understand how all these pieces of 3D content and animation and behavior and simulation and texture and everything come together. And it was open sourced by Pixar. So Pixar made Toy Story and Cars. Had to come up with a data format to let all their animators work together across these huge, great projects, rather than here have a big animation file, do something with it, have a big animation file. It was let us all work on this scene together for a movie, and this is how this is going to happen. This bumps into this, that kind of stuff. That got open sourced. NVIDIA picked it up. Autodesk are part of it as well, and companies like Siemens in the industrial space are engaged with it. And so this is all about representing across any tool set elements of what you can change in a not just a 3D environment, but a whole interactive, understandable environment. It's not where the stuff runs, but it's how you describe it. And I think OpenUSD is certainly one to watch. Again, we're back in fractal territory though, because whether you're talking about a file format for like JPEG or something, or a movie file format, or OBJ files just for 3D, we're kind of .usd files for the next stage of how's all this stuff come together. But it's a complicated file format, but with a lot of things in it, but it's one to watch. Then there's kind of bread and butter stuff here of this is where a lot of the stuff has started to come together of IoT, Internet Things, and digital twins, two buzzwordy things. Internet Things, people often think IoT, oh well, it's fridges or watches or pointless or just connecting things, but that kind of stuff. But in industrial context, being able to instrument existing machinery in a way that means you don't have to go and stand in front of the dial to look at it has become incredibly important. So we get industrial IoT sending sensor data over a network from an existing machine. It may be a new machine with all the stuff in it, or it may be a sensor stuck on the machine to say this has got hot, this is going fast, this needs fixing. But they're then sent over a network to kind of a digital version of themselves. It doesn't have to be a visual representation of it, but it's a digital version, which tends to be called a digital twin because it's a live up status, operational status of that machine. Might be one piece of information or 100,000 pieces of information. Could be the one machine, could be the whole factory, but we're in a digital twin space there. And so we've got a digital transformation there of physical processes. But also there's the potential for this thing to be able to send control data back over the network, like using private 5G, for instance, in a factory, to say, here's an important piece over the network slice of control information that you need to do now, not wait, this is priority one, go. But also, this is where we end up with computing being put on machinery to deal with some of these pieces of information and data and stuff. And so we end up with edge computing, we end up with machine learning models and AI on machines so that they know when to start and stop and up and down and change and warn and do all the things machines need to do. And then off in the digital twin space and where we're sending stuff, there's a lot of cloud use of cloud there, and that's where AI predictive maintenance lives, because that's where all the data gets aggregated from all the machines to know what to do. So we've ended up with cloud and edge and a bunch of AI and all sorts of stuff. And then on top of that, we've got some of the reality stuff in being able to give a worker some information, an engineer on the shop floor, some information in a headset or on a tablet about the machine that they're stood in front of, not just and actually knowing where they actually are, so you can point to the bit that needs fixing, or you can point to the bit that don't touch, or the order to perform the operation. And so this is all starting to happen. And so AR on its own is great, but when it's wired into stuff like this, you're making a significant difference to the whole manufacturing process. And this is all Industry 4.0 stuff, and it's called Industry 4.0. It used to be Industry 4.0 in German, and because the German government started it, but it's kind of it's become adopted and kind of Americanized effectively to Industry 4.0. So if you hear that, it's this kind of stuff to some degree of level. Again, it might not be everything all at once. People tend to start with sensor data. They may or may not do control data. Their AR stuff is coming, and some people are using it, but it's on its way. But then this stuff works the other way around, and this is where more modern developments are happening already. In that if you're going to build a machine or a factory or something, you start digitally. Now, a lot of things are built with CAD anyway. But so all the stuff that's been built digitally has been built, and then they can basically print out the design and give it to somebody to make. A bit like an architect doing a 3D model and then making a blueprint and giving it to the builder. But we're getting to the point now where people are building the entire thing, typically, might be defined in OpenUSD, complete factory and all its machines and all the parts and all the components, built as a full simulation down to the last bolt. And then that helps you validate the design of the thing that you're going to do. That might be a multi-billion-dollar factory, or it might be a $2 machine, but multi-billion-dollar factories work better. And taking that digital factory or digital place, you can then train autonomous robots and even physical human staff in that virtual environment. And so an autonomous robot can run around and around and bump into stuff until it's worked out what it needs to do. And that means when you actually build the real place, you've already got fully operational autonomous robots and staff, and where everything is, and it all works. So as a design validation, I know the physical world breaks everything, but as a design validation, we've got this digital thread from it's not really a digital twin because it's not a twin yet, but from digital design to the actual thing. And of course, that can lead to all the other things that we didn't even have on the list, like 3D printing of parts and autonomous assembly and things that help create the physical thing that you're going to run, particularly, as I said, in the industrial space. Because once you've got it running, which, we're kind of in yin and yang and fractal space here, we end up with being back to an operational digital twin. So that same thing that was designed now can become how we run it. And this loop is happening now, and you will see industrial metaverse in a lot of places. And that's what this means. And that's why I said metaverse isn't just dancing around and larking around in a game environment, even though that's good fun to do. AI, all the rage. You've probably all been sick of hearing about AI. I kind of had mentioned some of it before, but we've got terms like machine learning, which is a way to model and reason from data, some structured, some unstructured. And we've got and a quick question. IoT and IoE, I think they're just people stick letters on everything. I mean, we have IIoT and Internet of Everything and Internet of Things, and so Internet of Everything is the kind of final evolution where everything's connected anyway, if that's the IoE you mean. But I tend to use IoT as the thing just because it makes it easier to stick with that. But in the industrial space, they usually put the extra I on, so you have industrial IoT to somehow make it special and different. And Internet of Everything is when everything ends up being connected, which was kind of getting to it in many ways, because we don't just slap sensors on things; it's built into everything now. I hope that helps there. So machine learning, some structured and reasoning through data. We've ended up with these large language models, which are all the rage that's kind of kicking off at the moment. And these are models specifically trained to often predict the next word needed to be delivered in something, which has led to a whole load of interesting generative AI stuff, much of which the images in here have been created with Gen AI. And so we've ended up with ChatGPT and things like that to do with text and Copilot and Midjourney and video. But there's also stuff now building 3D content and 3D spaces and places for the metaverse. So again, this is all this stuff kind of looping into itself and being all part of the same pattern. And then we've got GANs, general adversarial networks, which I almost can't say. And that's where you get a couple of these things and chuck them at one another until one of them wins. We used to call that core wars back in the day when we used to write code to try and take out somebody else's code. But one of the things I want to suggest is that lots of people are enamored by this because it is very clever stuff, but they kind of, it's really less of a sentient person or thing, which is what some people think it is, because that's how these things often present, and more of a glorified filing cabinet, albeit a very expensive, very well trained, very well stocked filing cabinet. But think of a lot of these Gen AIs as it's got everything in it, and you find the thing you need and it comes out. It just finds it for you more quickly. So again, we're in yin and yang and fractal patterns all in one, because this is everything and nothing all at the same time. And the levels of pattern and the reasoning and how that works, it seems like magic sometimes, but it's, when you zoom in, it's not. It's the same things going on in compute that we've often had, just presented in a much cleverer way, or much further up the stack if you were doing it zoomed out further on Mandel set. A couple of other AI terms that pop up that confuse people. RPA, robotic process automation. It's got nothing to do with physical robots. This is about linking applications and processes. It's an enterprise systems thing. And robotic as a word gets messed up in all sorts of places. And I think this is probably the worst place that it fits. But that's the terminology used. And then of all the autonomous vehicle-y thing, AGVs, autonomous mobile robots, UAVs, and then cobots, collaborative robots, which are an interesting development in robotics, where, again, particularly in industrial, but where a robot will adjust to the skill and the speed and the effort of the person engaged with it. So it's like another person working with you effectively, but without it being a person, having just said, don't think of it as people. You know, the example, there's a great example that Omron build every year of a table tennis robot. So it serves and returns and stuff, and it can obviously beat the player instantly because it can see where you are and hit it and just knows and predicts where the thing is. But it doesn't. It tunes itself to the skill of the player to help them get better at playing table tennis. And so you have to kind of wonder where some of those things might take us. And then non-player characters, another AI use in games. Typically, we've had characters that are scripted or basic. I mean, there's been a lot of AI in games for a long while, in all sorts of ways. But now we've got things like InWorld.ai that are talking to LLMs to bring together a character so that it has its motivations and why are they doing stuff and a backstory, and they'll only behave in that way, not go off and do something weird. And then, of course, we've got people talking about artificial general intelligence, which is a concept about, I mean, this takes us into weird philosophy. Is it actually thinking? Is it real? Is it sentient? And it's a long way off, or is another question. Again, we've got filing cabinets at the moment, so it'll take a little while for us to potentially get to there. My sci-fi author head is going, oh God, that's going to be tricky, isn't it? Because you get the whole dystopian thing of this going on, especially when combined with robotics, because you then end up with a much more intelligent being, but with a physical presence, or hooked into all our systems through robotic process automation. But let's not dwell on that one just yet. Instead, we'll freak out on cybernetics. So cybernetics is basically using tech on yourself and doing things to yourself. I grew up watching $6 Million Man. I think they're remaking it now, but you know, they rebuilt him, and there's a lot of medical use of prosthetics and things with much richer compute power to help people, and we often end up in this kind of cyberpunk sci-fi stuff. There's a bunch of stuff going on with brain-computer interfaces. There's Musk's Neuralink, which is actually drilling into the brain and attaching to it. much scarier, but there's things that are headsets and that sort of send some of your brainwaves and things. And then we've got the whole body hacker movement where people are putting technology into their bodies, which is much more, as you can see in that image, though that's not me. And people have RFID chips, and obviously Professor Warwick was doing this, or no, Professor at Warwick University was doing stuff on this for years. But we've also now got biohackers that are doing homebrew gene editing with this CRISPR technology, clustered regular interspace short palindromic repeats. Anyone? So, and this is an example of what's going on there, because there is actually a website. I'm not endorsing this website. It's just this exists, and once this stuff exists, people do it and they click on it and they buy it. But where people can buy gene editing kits and tools and experience on gene editing. Now that's a whole level of technology. I'm a software engineer by trade. I'm usually talking about tech, wired in tech. Yes, and yes. So there's but this is another level, and I don't know where this is going to go, but it's happening. People do it. You may not like it, same as the body modding stuff, but it is going on. And then we're just getting nearly to the end, so you can brace yourself. So cryptocurrency and blockchain, all the rage for a while, sometimes on and off. Blockchain, a distributed ledger, no central point, so digitally understanding something that's happened and the provenance of something in a supposedly completely reliable manner, because you distribute the ledger so that everyone has a copy of it effectively, so it's not all held in one place. The concept is brilliant. Some of the executions have not been, and we'll see where that goes. I still think with all these things, I think there's a future for it. Then got the kind of cryptocurrencies that typically sit on a blockchain. Blockchain doesn't just have to be about cryptocurrencies, but a currency that's about a digital value of something. In the case of Bitcoin, calculating a value out of a formula, and the first person to hit that value wins that Bitcoin and puts it on the blockchain and owns it. It's rare, so it has value. But we've ended up with huge crypto mining rigs doing a whole load of stuff to try and dig out this money, so using massive amount of power and stuff like that to get to those. And then we've had NFTs, non-fungible tokens. They still kind of sit around. Again, this is a receipt for a thing that sits on some sort of blockchain, and it's usually some sort of digital artifact or something that got made or won or bought. And all these get traded on digital stock exchanges, and there's been a whole bunch, as you know, big scams. The FTX exchange, huge thing going on. People just grifting on NFTs, wallet hacking, theft, pyramid schemes. The whole thing's a wild west, just like the web was back in the early days. But I think it will all settle at some point, because some of the stuff, the concepts are really useful, and knowing you own stuff and who owns it and where it came from. I mean, that's Antiques Roadshow, isn't it? When it comes down to it, what's the provenance of this painting that makes it more valuable? So there's a desire in society to know where stuff comes from. But comes and goes, good and bad, yin and yang. Now there are some combinations of words that kind of pop up in this, like fintech and agritech, edutech, biotech, martech, space tech. Basically, you just stick tech on the end of things, and it's mostly the same technology, but with a few specializations. And again, you kind of dive into these, and the devil is in the detail then, but you can kind of sit back and go, yeah, well, agritech and fintech, it's sort of the same thing, isn't it? Whether you're farming a field or you're farming a Bitcoin mine, it's all farming. So in many ways, those sorts of patterns you can find. Not to dismiss any of them, because they're all kind of important. And then we have Industry 4.0, which I just said, but there's 5.0 and 6.0, just like the 3, 4, 5G thing, more of the same. All buzzwords, all acronyms, and they all just try and do each thing better with a little bit more added digital. And so again, we're in Mandelbrot territory. It's fractal, it's the same stuff. Pick one of them, dive in, you'll find the patterns you recognize. Then there's just a few wider concepts. Open source, huge for everything. Doesn't just have to be software anymore. Often confused by businesses with free. It's not free. It's about contributing and all working together for a common good. But we'll get there. Web3 is kind of associated with internet, web, and metaverse, and a lot to do with NFT and crypto, and is trying to make web and consider web as a more distributed, non-centralized thing, as if you think it is all kind of quite centralized in a lot of ways. So we'll see where that goes, but that's another underlying combination of things, that some of which have gone a bit haywire for now. And that leads us on this kind of final bit. So when you apply all of these, and they're not all listed here, but AI might enhance what we do or could put us out of a job. Industrial metaverse makes making stuff easier, but they might make too much stuff because they've got suddenly capacity to do it, and that's a waste of resources. Compute power, quantum makes it secure, but it's easier to crack existing stuff. So that's a balance there. Metaverse, remove all our physical boundaries and help us understand one another. Does it become so good that we don't bother ever leaving it? So that's it. In the end, as I say, there, it's down to us as a global community, not just BCS, but just the world, to make all this stuff work, because it's not the technology doing the bad thing. And if that sounds familiar, we've got a bunch of yin and yang there. So all the fancy words, all the wizardry, it's not the tech usually, it's us that we have to worry about. And that's the end of my techno hippie bit, but just the kind of and finally thing. In trying to make this, I was trying to get Gen AI to make some of these images, and I would say it's got a way to go yet, because trying to get it to understand a robot and a filing cabinet and a tin can phone system was tricky. No matter how long I made the prompts, I got some weird and wonderful, interesting results, either rusty robots or not the right filing cabinets. So all this stuff sounds like it's easy. There's a lot of curation that has to go on and a lot of bouncing ideas around. So it's not this instant thing where you just go, AI, sort this problem out. And we know it's not, because if any of your programmers, it's not. As the specification is always wrong or gets misinterpreted. To nail down the exact thing you need is tricky and complicated. And so telling an AI what you need is tricky and complicated. But that's not stopped me trying. So I looked at my I clicked too early there, I'll have to press play again. So I'm still going to try and make a movie of my reconfigure book with AI, or with AI assistance. And so in the opening of the movie, Roisin is busy tapping away trying to get off the grid while she's being traced. So I've ended up generating this from Luma, and each iteration of these video things, we get closer to it actually being able to do what I want to do. At the moment, I've got like 2 seconds there, which is not quite enough for a feature film, but it's stuff that is worth exploring, and it all starts to pull a lot of this stuff together when you start trying to work out how you specify what you want. And with that, thank you very much. I've reached the end of the hour of blasting through that, and I hope that's been interesting in some way, or freaked you out and you want to shout at me and say that's not right, or oh, hang on, I'll go and think about this in a different way. And that's me. And I'm open to any questions. I know we've kind of hit the end of the hour, but I'm happy to answer some more. And yes, there is an MP who used robotic arm. Sorry, I didn't get to that before. But yes, well, there was. I think he resigned. But yes, those robotic arms and robotic legs are particularly impressive use of technology and robotic technology.